Meet ARL and Buddha, two very different opponents in a very simple physical AI experiment. The arena is built from two visual markers. A camera watches the scene from above, while the program continuously estimates the position of each marker. At the center is a small servo motor carrying a red arrow. This is the only moving part, so the system has just 1 degree of freedom. The arrow can rotate toward ARL, or toward Buddha. On the left side of the screen, the computer vision program processes each camera frame. It detects the two markers, identifies their orientation, and converts what the camera sees into useful coordinates. Those coordinates become the input to a simple decision process. The program compares the two sides of the arena and chooses where the arrow should point. The decision is then sent to the microcontroller, which commands the servo motor. This creates a complete perception and action loop: observe the physical world, calculate a response, and produce a physical movement. It may look like a small tabletop demonstration, but it contains the essential ingredients of physical AI. There is a sensor, a model of the environment, a decision, and an actuator that changes the real world. As the tracking updates, the arrow responds to the relationship between ARL and Buddha. The software is not merely displaying a result on a screen. It is controlling a physical object in real time. The simplicity is the point. With only one moving axis, every stage of the system is easy to see and understand. From here, the same idea can grow into robots with more joints, more sensors, and more complex behavior. ARL vs Buddha, a playful arena, a single servo, and a compact example of physical artificial intelligence.